Okay, guys, we are on Chapter 12, Lesson 1, Angles and Degree Measure. Now, you have done plenty of angle measuring before, but in this lesson, we are opening up a new study called trigonometry. Trigonometry is simply an ancient Greek word which means triangle measurement. And trigonometry, therefore, is the study of triangles and angles. So we're going to be looking at triangles, and to start us off, we're going to make sure we understand how to take a measurement of any angle. You need to remember that an angle is measured in our math history by degrees, and a degree is 1/360th of a complete revolution. So you start here, and if I was to take my pencil and spin it like this all the way around till it landed back where it started, that's 360 degrees. So 1 degree is 1/360th. We're defining a whole spin as 360 degrees. That's where that number comes from. Now, most angles that we work with in geometry are somewhere between 0 and 180 degrees. So if we start here, and we call this 0, like on a protractor, then we spin it, and then we'll stop here, and we'll call this 180 degrees. We don't work with angles like this, because then we'd want to measure this way instead of this way, but you can't. Okay, we can make any angle we'd like by using a rotation that moves one of its sides, called the initial side, and rotating it until we land at what we're going to call a terminal side. Okay? Now, if we rotate counterclockwise, okay, so we're going to pretend like we start with an initial side, like this, and we rotate counterclockwise. We're going to call that a positive angle. For example, suppose I stop right here, and it goes all the way down like this. That would be 225 degrees positive. But now suppose I rotate it clockwise. This is the initial side, and this is the terminal side. That would be negative 60 degrees. So we're going to deal with positive degrees and negative degrees. These are called directed angles. An angle can be positive if it rotates counterclockwise, and negative if it's rotated clockwise. Okay, so we'll need to understand what's meant by a positive angle, rotates this way, and what's meant by a negative angle, it rotates this way. That'd be negative 60 degrees. Okay, directed angles, it matters which way you go. And we're going to go ahead and start when its initial side, let me get a fresh piece. We're going to call it standard position, because, you know, where does the starting side, where's the initial side? If you have an x-axis here on a coordinate plane, we're going to say an angle's in standard position when the initial side lines up with the positive x-axis. Okay, so you could say that this is the first quadrant, second quadrant, third quadrant, fourth quadrant. This is a first quadrant angle. This would be a second quadrant angle, third quadrant angle, and fourth quadrant angle. Now, let me start a fresh one here. It's too messy. If you start, so here's standard position. The initial side coincides with the x-axis. Now suppose you rotate this thing and then it stops right here and it lands on an axis. We call that a quadrantal angle. Wow. A quadrantal angle. This would be 270 degrees positive. Or, if you rotated it that way, it would be negative 90 degrees. Okay, now, something else. Because we're dealing with angles in a slightly different way than you may have dealt with them before, you need to be aware that one ray may end up representing the terminal side of multiple angles. So this is in standard position. If I start here and I rotate this way, that's 150 degree angle, initial side to terminal side. But suppose I do the same thing, but instead of stopping right here, I go around and then stop. It looks like it's in the same spot, but this angle is actually 360 degrees plus the 150. That's a 510 degree angle. Okay, you can even go more than one time around. So I'm starting here, standard position. The initial side is on the x-axis. 1, 2, boom. Okay, there's my terminal side. I have 360 plus 360 is 720 plus 150 is 870. This is an 870 degree angle. Okay, one other example like that. Suppose I start here, standard degree, or standard position, and then I rotate this way, and then end up right here. Well, that is a negative 210 degree angle. All of these are called coterminal. They share a terminal side. They are coterminal. And there's a little equation that we could use to figure out these different angles. So since the magic number is this 150, so I'm going to say 150 degrees plus 360 degrees, however many times you want. So for example, on this one, this would be 150 degrees plus 0 times 360 degrees. No 360 degrees, which would make it 150. This is 150 plus 1 360. This one would be 150 plus 2 360s. Now this one's a little trickier. This would be 150 plus a negative 1 360s. So any number of turns you want to do around this circle, you can using this simple formula. And so, okay, let's get to our first example. Could you write a formula of your own to find all the angles that are coterminal with a 30 degree angle? Okay, so what's the magic number? The magic number is 30, and we're going to add however many 360s we want. That's a recipe, a formula for all the measures of angles coterminal with this angle. Now go ahead and pick a couple of ends and find two positive angles. So we could say 30 plus 1 times 360, 30 plus 2 times 360. There we go. So 390 degrees would be coterminal, and 750 would be coterminal. Now, can you plug in and find some negative ones? Well, sure. So let's say 30 plus negative 1 times 360, and 30 plus negative 2 times 360. So this would be negative 330 degrees, and this one would be negative 690 degrees. So you can use the formula and find coterminal angles. Okay, one more thing. Suppose 1 degree, 1/360th of a revolution, a 1 degree is not precise enough. Well, you can split a degree into 60 minutes. So if you have 1 degree, you could slice that, dice that up into a minute. 1 minute, this little symbol means minute, is equal to 1/60th of 1 degree. So we have degrees, and then we have minutes. Now suppose a minute is not exact enough. Just like on a clock, you can take 1 minute and divide it into 60 pieces. So 1 second, and the double apostrophe means second, is equal to 1/60th of 1 minute. So we have degrees, minutes, and seconds. A lot of calculators will convert degrees, minutes, and seconds into something like 30.2498 degrees. So you'll see it sometimes with degrees, minutes, and seconds, and other times you'll see with decimal degrees. So for example, if you have 14 degrees, 36 minutes, and 54 seconds, you can convert it to 14.615 degrees. You can use a calculator, or you can do this. 14 plus 36 sixtieths plus 54 60 times 60s, 36 hundredths, and you'll get this. Or you can plug it into a calculator. The same thing happens by going backwards. Last one. Suppose I ask you to take a decimal degree and convert it into degrees, minutes, and seconds. How can you do that? Well, you know that 72 degrees plus 0.568 times 60 raised to the to the minutes. That's how many minutes there are. Okay, so 72 degrees plus 34.08 minutes. Well, 72 degrees plus 34 minutes plus 0.08 times 60 degrees, 60 seconds. So we have 72 degrees plus 34 minutes plus 4.8 seconds. Now, we're not going to go smaller than seconds, so we round 72 degrees, 34 minutes, 5 seconds. There it is. Okay, now, a lot of times we will end up using capital letters like this to name an angle, or we'll use a Greek letter, theta, or phi, or alpha, to name angles. Okay, so for example, we'll say theta is equal to 20 degrees, or angle A is equal to 20 degrees, or we'll say the measure of angle A is 20 degrees, or simply angle A is equal to 20 and degrees, and we'll leave off the little degree symbol. Okay, that's it, guys. Go ahead and start the work and let me know if you have any questions.